Hello students, this is Usha from G.K.JAIN High Secondary School, Raipuram. Today we are going to see the chapter Optics Part 4 in 12th Standard Physics. So we are going to see about today thin lens and lens maker formula. Today we are going to see 12th Standard Physics Optics Part 4. So we have already studied that the refraction at a plane surface. The refraction also takes place at spherical surface between two transparent medium. The law of reflection holds good at every point on the spherical surface. Today we are going to learn about the thin lens. A lens is formed by a transparent material bounded between two spherical surfaces. In a thin lens, the distance between the surfaces is very small. If there are two spherical surfaces, then there will be two centers of curvature C1 and C2 and correspondingly two radii of curvatures R1 and R2. A plane surface has its center of curvature C at infinity and its radius of curvature R is also infinity. Now we'll see the two types of focal points. One is primary and another one is secondary focal point. As the thin lens is formed by two spherical surfaces, the lens may separate two different media. That is, the media to the left and right of the lens may be different. Hence, we have two focal lengths. The primary focus F1 is defined as the point where an object should be placed to give parallel emergent ray to the principal axis. The secondary focus F2 is defined as the point where all the parallel rays traveling an image on the principal axis. That is shown in the diagram. Next we will go into the lens maker formula and lens equation. This is the diagram shown over here. Let us consider a thin lens made up of a medium of refractive indexes N1 and N2, and N2 is placed in a medium of refractive index N1. Let R1 and R2 be the radius of curvature of two sphericals 1 and 2, and P be the pole that is marked in the diagram. Consider a point object O on the principal axis. The ray which fall very close to P after refraction at the surface 1 forms image at I dash. Before it undergoes, it has to again refracted by the second surface. Therefore, the final image is formed at I. The general equation for the refraction of a sphere is given by the equation N2 divided by V minus N1 divided by U is equal to N2 minus N1 divided by R. For the refracting surface 1, the light goes from N1 to N2. So we have N2 divided by V dash minus N1 divided by U is equal to N2 minus N1 divided by R. Because they move from the first surface till we have to calculate to the image of I1. So we have this equation. Next we have for the refractive indexes surface 2, the light goes from the medium N2 to N1. So now we'll have the object to be I1 and the image to be I. So we have N1 divided by V minus N2 divided by V dash is equal to N1 minus N2 divided by R2. Adding the above two equations, then N2 divided by V dash will get cancelled. We have N1 divided by V minus N1 divided by U is equal to N2 minus N1 into 1 by R1 minus 1 by R2. So on the left hand side N1 is common, we'll take it out and then we'll bring it the N1 to the other side. So on further simplification and rearranging, we'll get 1 by V minus 1 by U is equal to N2 minus N1 divided by N1 into 1 by R1 minus 1 by R2. On further simplifying, we'll get 1 by V minus 1 by U is equal to N2 divided by N1 minus 1 into 1 by R1 minus 1 by R2. If the object is at infinity, the image is formed at the focus of the lens, as we have learned the conditions in the before classes. Thus, for U is equal to infinity, V will be equal to F. Then in substituting this value in the above equation, I'll get 1 by f minus 1 by infinity is equal to n2 divided by n1 minus 1 into 1 by r1 minus 1 by r2. 1 by infinity is 0, so I'll get the equation as 1 by f is equal to n2 divided by n1 minus 1 into 1 by r1 minus 1 by r2. If the refractive index of the lens is n2 and it is placed in air, then n2 will be equal to n and n1 will be equal to 1. Then the equations become 1 by f is equal to n minus 1 into 1 by r1 minus 1 by r2. This equation is called as lens maker formula. The next topic is lateral magnification in thin lens. See the diagram. So we have taken a thin lens, O dash be the object at a height h1 placed on the principal axis, which is height perpendicular to the principal axis. The ray OP passing through the pole of the lens goes undeviated. The inverted real image I dash formed at a height h2. The lateral or transverse magnification M is defined as the ratio of height of the image to that of the object. That is, M is equal to I dash divided by O dash. From the two similar triangles PO dash and triangle PI dash, we can write I dash divided by O dash is equal to PI divided by PO. Applying the sign conversion, we'll get minus H2 divided by H1 is equal to V by minus U. So substituting this value in the magnification equation, we'll get M is equal to minus H2 by H1, which is equal to V by minus U. After rearranging, we'll get M is equal to H2 by H1, which is equal to V by U. The magnification is negative for real image and positive for virtual image. So the equation for magnification by combining the lens equation with the formula for magnification as M is equal to H2 by H1. Next is power of a lens. Power of the lens is a measure of deviation strength of a lens. That is, when an instant ray is fall on a lens, then the degree with which the lens deviate the ray is determined by the power of the lens. So the power of the lens is inversely proportional to focal length. The power of the lens P is defined as the reciprocal of its focal length. So the power of the lens P is equal to 1 by F. The unit of power is diopter, which is given as capital D, and 1D is equal to 1 meter inverse. Power is positive for converging lens and negative for diverging lens. Next topic which we are going to see is prism. So as you all have seen the prism and you have studied about the prism in your 11th standard, we'll talk about the prism. A prism is a triangular block of glass or plastic. It is bounded by three plane faces not parallel to each other. Its one face is grounded, which is called base of the prism. The other two faces are polished, which are called refracting faces of the prism. This, when we go to the lab, we can see we have an experiment to do in the 12th standard by using the prism. So the base will be little bit blurred, which is not very clear. The other two faces are polished and they are called as here refracting faces of the prism. The angle between the two refracting faces is called angle of prism or refracting angle or apex angle of the prism. Next is angle of deviation produced by prism. So here the diagram shows a ray of light PQ is incident on one of the refracting faces of the prism. The angle of incident and refraction at the first face AB are I1 and R1. So when they are moving to the prism, they are going to move in a straight line. The path of the line inside the prism is QR. The angle of incident and refraction at the second face AC is R2 and I2. RS is the ray emerging from the second face. The angle I2 is also called angle of emergence. The angle between the direction of the incident ray PQ and the emergent ray RS is called the angle of deviation D. Okay, now we draw two normal at the point of incident Q and emergent R are Qn and Rn. They meet at a point N. The incident ray and the emergent ray meet at the point M. So now we'll come to the derivation part. The deviation D1 at the surface AB is angle RQM, which is equal to D1, which will be equal to I1 minus R1. The deviation D2 at the surface AC is angle QRM, which is equal to D2, which will be equal to I2 minus R2. Total angle of deviation D produced is, total means we'll add together. So we'll get D is equal to D1 plus D2. Substituting for D1 and D2 from the above values, we can write D is equal to I1 minus R1 plus I2 minus R2. After rearranging, we'll get D is equal to I1 minus R1 plus I2 minus R2. Let me consider a quadrilateral AQNR. Two of the angles at right angles. Therefore, the sum of the other two angles of the quadrilateral is 180 degree. So we can write angle A plus angle QNR is equal to 180 degree. For the triangle QNR, we can write the triangle. So overall will be equal to 180 degree. So we'll get R1 plus R2 plus angle QNR is equal to 180 degree. Comparing the above two equations, the right hand side is equal and left hand side when we compare, angle A will be equal to R1 plus R2. Substituting this value, we'll get the deviation D will be equal to I1 plus I2 minus A. Thus, the angle of deviation depends on the angle of incidence, angle of emergent and angle of the prism. So for a given angle of incidence, the angle of emergence is decided by the refractive index of the material of the prism. So the angle of deviation depends on the following factors. What are they? First one is angle of incidence, second one is angle of the prism, third one is the material of the prism, and fourth one is wavelength of the light. Next is the refractive index of the material of the prism. So at minimum deviation, we can take I1 is equal to I2 is equal to I and R1 is equal to R2 is equal to R. Now the equation becomes D is equal to I1 plus I2 minus A, which we have seen in the before equation. So now you substitute here, you will get 2I minus A. From this, I will be equal to A plus D divided by 2. So in the same way, R1 plus R2 is equal to A. So 2R is equal to A. R will be equal to A by 2. Substituting I and R in Snell's law. What is Snell's law? So N is equal to sin I divided by sin R. So instead of I and R, you substitute these values. So we'll get N is equal to sin A plus D by 2 divided by sin A by 2. It is used to find the refractive index of the material of the prism. The angle A and D can be measured experimentally. Hi students, you all have now know how to derive the lens maker formula. Thank you. Once again, we'll meet you in the next video.